So we were talking about structures of homologous series. Quick recap: homologous series is a family of organic compounds having certain common properties like similar chemical reactions. They show trends in physical properties. They have the same functional group, which is basically the presence of a particular structure in the molecule that determines the chemical properties of the molecule. They have the same general formula, and successive members differ by CH2. Now, we were talking about alkanes. Alkanes were hydrocarbons. They're a family of compounds that only contain carbon and hydrogen atoms, and they are saturated, which means that all the bonds that they make are going to be single bonds. Anyway, so this is your typical alkane. All of these are alkanes. And I told you that the general formula of alkane is CnH2n plus 2. So if you don't want to draw the entire structure and you just want to figure out what is the formula, you can apply this formula where n is the number of carbon atoms. So if n, for example, over here comes out to be 4, there are 4 carbon atoms. So H would be 4 into 2 plus 2. So that's 8 plus 2 is 10. And you can count it has exactly 10 hydrogens. Now, we were at this point, we were trying to name alkanes. And I told you that when it comes to naming, in your course, you'll only be asked about straight chain alkanes. Straight chain alkanes are those where the carbons are in one line. Okay, I told you that they were branched hydrocarbons. These are branched. That the carbons are not in a straight line. I mean, they're kind of like a tree with branches. The carbons are not in a straight line. These are cyclic, where the carbons are in connected in a cyclic structure. These are straight chain molecules, where the carbons are all one after the other. Now, coming to naming alkanes, when it comes to naming alkanes, the thing is that alkanes, almost all hydrocarbons are actually named in the same way. That they're based on the number of carbon atoms, and it's going to start with meth. Then this is the chemistry of this is the counting of organic chemistry. It's meth, prop, bute, pent, hex, hept, and this is how far you should remember. This is not required, but it wouldn't do you any harm if you even remember that. Uh, Now, for an alkane, the name always ends with "ane," so the suffix is always "ane." So, for example, if I want to draw butane, now the starting point "but" actually represents that there are 4 carbon atoms. So I'm going to have 4 carbon atoms. So that's one, two, three, and 4. And I just need to fit in the hydrogens. All of them would be single bonds. So this one would have 3 hydrogens. This carbon will have 2 hydrogens. This will have 2 hydrogens, and this would have 3 hydrogens. So this is a molecule of butane, and so on. So I can make any molecule, and so we can have ethane. Now ethane is going to be what? Eth stands for 2 carbon atoms. So ethane is just 2 carbon atoms, and it's a saturated molecule. So bring in the hydrogen. So there would be 3 hydrogens with this, and there would be 3 hydrogens with this as well. So this over here is a molecule of ethane. So based on this, you can draw any structure. So now
Yes.
चलो ठीक है. Now moving to another hydrocarbon, uh, and moving to another homologous series. Okay, that's the first one. That's alkanes. Now the other one is going to be pretty much. It's going to be very similar. They're called alkenes. Okay, except for a few things, they are very similar to alkanes. Now alkenes, the general formula is CnH2n. As the first thing, what is an alkene? The alkene is a hydrocarbon. That's point number one. So it only contains hydrogen and carbon atoms. So this is also a hydrocarbon. Point number two is that they are unsaturated. They are unsaturated hydrocarbons. Now, the word unsaturated means that there's going to be at least one double bond between the carbon atoms. Remember, between the carbon atoms. So there's going to be at least one double bond somewhere. So they're very similar to alkanes, except that they have this thing, a carbon and carbon double bond. So for example, I have a molecule, and let's say it has a bunch of carbons, and somewhere in between there's a double bond between the carbon atoms, and this could be anywhere. And then you start adding the hydrogens. So this over here would be making two more bonds with hydrogen. This over here would be making a bond with hydrogen. This is fourth bond with hydrogen. This is three hydrogens. And then you have this carbon atom, which is going to be bonded to three hydrogens as well. And so anyway, so because it has the functional group, this is the particular structure. This is the functional group of any alkene. So this is going to be our functional group, and this is going to be called uh, called an alkene if it has it. And minimum is one. You could have more than one as well. So what's the general formula? The general formula over here again is N is the number of carbon atoms. So if it has one, two, three, four, five carbon atoms, according to the general formula, if it has five carbon atoms, H would be 2, and 2 into 5, that's 10. You can count the number of hydrogens. This has three hydrogens. This has three hydrogens. That's 6, 7, 8, 9, and 10. So you can directly figure out the formula of the molecule by just using the general formula. But it won't give you the structure. It would give you. I mean, this is the structural formula. Remember this. This is the structural formula. This is known as the molecular formula. The molecular formula gives no information about how the atoms are connected. And this over here is the structural formula. The structural formula gives you exactly how the atoms are arranged in relative to each other. Who's bonded to what? So the structural formula gives you a lot more information compared to a molecular formula. Acha, risky naming. Prefix is the same. You're going to have a prefix, and that depends on the number of carbon atoms. So it's going to be exactly the same thing: meth, eth, prop, but, etc. The suffix is going to be different. The suffix is going to be "-ine". So the suffix is the ending part. So the name would start with the prefix, the number of carbon atoms, and it would end with "-ine". So for example, you have this molecule over here, and that's ethene. Now, according to our knowledge of alkenes, eth stands for two carbon atoms. So that means the molecule has a total of two carbon atoms. So that's two carbon atoms. And there's supposed to be, because it's an ene, it's an alkene. So there's supposed to be a double bond somewhere, which is there's no other place to put a double bond except between the two. This carbon would have two hydrogens, and this carbon also would have two hydrogens. So that's what ethene is. Similarly, propene would be very similar as well. Now, there's going to be one confusion, and that is somewhere in the middle, the double bond position, like where the double bond is located, it has to be mentioned. So, for example, if you look at the molecule over here, although it's an alkene, but the name is not telling us where the double bond is located. Like if I told you to draw this molecule, and you're not given the position at which the double bond is located, so the position has to be known where the double bond would be located. Now, over here, you didn't have an issue because there was no other position or available position. The double bond had to be there. So if I, for example, if I draw butene, so if I draw butene, the thing with butene is that but is how many carbon atoms? But over here is four carbon atoms. So that indicates that if it has four carbon atoms, it's going to have. So let's draw four carbon atoms. And remember, you're only going to be asked about straight chain. So in a line, four carbon atoms in a line. So but has four carbon atoms. Now the issue would be where do you put the double bond? Like it's an ene. So you have to sort of the name is kind of missing because the double bond position is not mentioned. So somebody could put the double bond over here and fill it up with hydrogens. So it's going to have this one would have two hydrogens, this one would have one hydrogen, this will have two hydrogens, and this one over here would have three hydrogens. Or if I ask someone else to make this make butene, he's going to take four carbon atoms, and again he would be confused where to put the double bond, and he might put the double bond over here in the middle. And now the two separate molecules that are being drawn, this will have four bonds, this would have three more hydrogens. I said, so now the confusion is that where do you put the double bond? Uh, so the double bond position has to be mentioned, and you have to tell them exactly where the double bond is. So, for example, butene would result in these two molecules, and these two molecules are different molecules. They're not exactly the same. Okay, the structures are different. So, so the name has to show that has to differentiate between the two. So the double bond over here is on the first carbon atom. So this one is called but-1ene. So that's where you add the position, right in the middle. The one indicates that the double bond is at position number one. So it is at position one. I said, what about the other one? If you count it, it's on the second carbon atom. So the double bond is at position number two. So this one over here is but-2-ene. So both of them are butenes, but one is but-1ene, the other one is but-2-ene. And remember that the position is always assigned from the side which gives the smaller number. So it's always assigned from the side which gives smaller, smaller number. You could have counted it from this side. So this is first, second, and the double bond is on the third carbon atom. Uh, Somebody must be counting from this side, so this is carbon number one. So you're going to count from the side that gives a smaller number. So one is but-1ene, the other one is but-2-ene. And also remember that you can't make the double bond over here because this molecule, let's say I shift the double bond one more place and I have the double bond at this last position. And there are all these hydrogens, and I said, so if you have a look at this, uh, these two are exactly the same. Okay, remember I told you that drawing the molecule upside down or sideways or bending it, as long as you're not changing it. These two molecules are exactly the same. You pick this up and you flip it around. You can put it upside left, right. Switch the side. Pick it up and put it the other way around. It's going to look like this. Okay, it's like, but try flipping like you flip things. Okay, try and flip this molecule left to right. this is what you're going to get. So these two molecules are not different molecules; they're exactly the same. This is structurally different. So this, so I'm going to cut this out because it's exactly the first one. ये बात clear है सारों को? Is this clear?